All right, we are going to solve this radical equation. So I need to get the radical by itself, so I have to get rid of this 3. So the opposite of plus 3 is minus 3. So I'm going to minus 3 to both sides. I now have a square root of x plus 9 equaling 4. Now, how do you undo a square root? You undo a square root with a square. So we're going to square both sides. And I now have x plus 9 equals 4 squared, which is 16. Lastly, to find x, you minus the 9 off to get it by itself. And I now have x equals, looks like 7. Now, with radicals, you want to check your work because you can have these extraneous solutions things popping up. So to check our work, I'm going to take the original function, x plus 9 plus 3 equals 7, and I'm going to put 7 in there because 7 is what we got as an answer. So that leaves us square root of 16 plus 3 equals 7. Square root of 16 is 4, so 4 plus 3, does that equal 7? Well, yes, it does. We are good. We checked it. It is not extraneous, so the answer to the first one is 7. So for this next problem, I want to get this fractional power by itself. And just so you know, that 1/3 power means a cube root. So to get rid of this, I have to add 1 to both sides. So I'm going to add 1 to both sides. That leaves me with 5x plus 2 to the 1/2 power equals 4. To get, not 1/2 power, that would be a 1/3 power. Don't want to change it. I can't do that. Can't change it like that. So how do you get rid of a 1/3 power? You have to cube both sides. Now, you can think about why does that work? Well, if you know your power properties, doesn't a power to a power, don't you multiply those? And when you multiply a third times 3, doesn't it make a 1 power? And that's technically what's happening. So what we're left with is just the 5x plus 2. Because the 1/3 times the 3 leaves a 1 power. And 4 to the third
48.
is 64.
What?
So now we are going to solve from here on. I have to get rid of the 2. So I'm going to minus the 2 off. I now have 5x equals 62. I now got to get rid of the 5, so I divide by 5. So I now have x equals 62 over 5. So there's my answer. It could be a decimal. It could be a fraction. That right there would be about 12.4. So let's check it, though. We have to check, check, check. Now, technically, you don't have to check this one. Here's why you don't technically have to check this one. If that's a cube root, do cube roots have imaginaries? No. Cube roots don't have imaginaries. So there's no errors to this one. The answers are what they are, unless you screwed up. Still worth checking, but you don't have to check a cube root. You don't have to. Extraneous won't pop up on cube roots. They'll only pop up on even powers, seconds, square roots, fourth roots, because that's where imaginaries come in. So I'm going to check just to check, but you don't have to for extraneous purposes. So as we check this one, we get, and I'm going to write it as a cube root. Is that okay if I change it to cube root, hopefully? Because a 1/3 is a cube root. I'm going to put 62 over 5 here, plus the 2, minus 1 equals 3. Again, I changed it from a 1/3 to a cube root. Are you okay? Those cancel. Leaving you the cube root of 62 plus 2 minus 1. And that right there gives you the cube root of 64, which is, the cube root of 64 is 4. And does 4 minus 1 equal 3? Well, yes, it does. So we did it right. It's always good to check. Even if you know it's not going to be extraneous, worth checking. Last question. I want to solve this. Now, if you try squaring both sides as is, you're going to get a big fat mess. So I got to get this over first. You have to isolate all radicals before you start powering. So I'm going to get this whole piece over. So what I'm going to do on this last one is I'm going to add the 4th root of 3x plus 2 over to this side. So I now have the fourth root of x minus 6 is equal to the fourth root of 3x plus 2. So I got the radicals isolated. Now let's try not squaring, but how do we get rid of a fourth root? We do a fourth power. So to get rid of the fourth root, I have to do a fourth power to both sides. And then it becomes a fairly easy question. All the radicals disappear, and we just have to solve this. First step, let's minus the 3x over. There's different ways to solve this, different steps. I decided to move the 3x first. That would be negative 2x minus 6 equals 2. Again, there's different ways. Some of you might have, by the way, moved the x over this way. I chose to move the negative 3x this way. So it's your call. But for what I did, I now have to get rid of my 6. So I add 6 to both sides from my way of doing it. And then I divide both sides by negative 2. So I now have x equals negative 4. Negative 4. All right. Now, is this an even or odd root? It's an even root, so I must check for extraneous for sure. Okay? We have to for sure check for those extraneous. So, let's do it. The fourth root of negative 4 minus 6 minus the fourth root of 3 times negative 4 plus 2. Does that equal 0? Well, let's see. That's the fourth root of negative 10 minus the fourth root of, well, negative 12 plus 2. Isn't that also negative 10? So, well, if we are dealing with imaginaries, that is true. But we're assuming we're not even talking about imaginaries. The moment I get a negative inside of an even power, that is impossible. So this is not possible. Even though, yes, in imaginary terms it is. But don't go there. This you cannot get. This is not real. Neither is this real. You can't subtract two non-real numbers. So this malfunctions. So what I do is I go up here, cross this out, and put no solution. Now, if you were to graph this to solve it, you would notice they don't cross. That would prove it if you graphed it. Kind of hard to graph these, though. Okay, there is another way to write the answer. Besides no solution, you could also say that negative 4 is an extraneous solution. You could also say that. So you can say this has no real solution, or you could say that negative 4 is an extraneous solution, meaning it's a solution that doesn't really work. We solved it right, but it's not working for some weird reason. So make sure whenever you have even powers, even radicals, to check for sure. Because even if you did it right, it could be wrong. We did it right. It still didn't work. Great. If it's a odd root, you don't really have to check, but still good to do it.